You just finished building a brilliant lightning-fast shopping app on your laptop. But now you face a terrifying reality, launching it to the entire world, where millions of users might try to visit at the exact same time. In the past, handling that kind of traffic meant buying stacks of expensive physical servers and maintaining a complex, messy server room yourself. This created a massive financial trap. If you bought too few servers, a sudden spike in shoppers would crash your app entirely. But if you bought too many, you'd spend a fortune on expensive hardware that just sat around collecting dust most of the year. Amazon Web Services, or AWS, solves this by acting like a massive pay-as-you-go digital megamall. Instead of buying and owning fixed infrastructure, you simply rent the specific building blocks you need, exactly when you need them. Moving from heavy physical hardware to on-demand cloud services turns launching an application from a massive upfront financial risk into an adaptable, precise science. First, we need to get customers to your store. Route 53 acts as the internet's GPS. When someone types your website address into their browser, Route 53 immediately translates that human-readable name and directs them to the correct digital destination. But there's a physical distance problem. If a shopper in Tokyo tries to load a high-resolution product image that's stored on a server all the way in New York, the load time will be slow and frustrating. This map illustrates how AWS solves the distance problem with CloudFront. This global delivery network takes copies of your images and files and caches them at local hubs worldwide. Now that shopper in Tokyo downloads the image instantly from a hub right down the street. That pairing Route 53's precise directions with CloudFront's local file delivery, you ensure that every customer gets a frictionless, instant experience, no matter where they are on the map. Once the customer arrives, they need a server to process their actual shopping cart. This is where EC2 comes in. EC2 instances are virtual machines, the active digital workers where your application code and backend logic actually run. Imagine what happens on a Black Friday sale. Instead of a steady trickle of shoppers, a massive, overwhelming crowd floods your application all at once, threatening to crush a single server. To prevent a crash, we use a load balancer. Think of it as a highly efficient traffic cop. It stands in front of your EC2 workers, intercepts the massive crowd, and smoothly distributes those requests across multiple servers, so no single machine gets overwhelmed. But what if the crowd keeps growing? Auto-scaling detects when your current servers are nearing their limit and instantly creates new workers to handle the load. When the sale ends and the traffic subsides, it automatically removes those extra servers. Combining a load balancer with auto-scaling guarantees your store stays open and responsive during the busiest peaks, while ensuring you never pay for idle servers during quiet hours. Behind the scenes, your app needs a place to store things. S3 is your infinitely scalable digital warehouse. It is designed strictly for holding unstructured files, things like product images, review videos, or PDF invoices. For organized information, like customer profiles and order histories, you use RDS. Instead of you spending hours on manual upkeep, AWS handles the technical chores like backups and updates automatically, so you can focus strictly on the data. Sometimes you need to run small background tasks, like generating a thumbnail every time a new product photo is uploaded. Instead of keeping a full server running all day just for this, Lambda acts as an invisible worker. It executes brief blocks of code only when triggered and then immediately turns off. By separating your file storage in S3, your relational data in RDS, and your background tasks in Lambda, your main EC2 servers are completely freed up to focus entirely on helping active shoppers. Now let's talk about keeping all of this safe. A virtual private cloud, or VPC, is the foundation. It creates a strict private network boundary, isolating your servers and databases from the public internet. Inside that VPC, security groups act as your individual bouncers. They are specific firewall rules that decide exactly who gets in. They might allow normal web traffic to reach your application, while instantly blocking any malicious access attempts. For the people actually working on the app, IAM acts like a set of digital keycards. It makes sure employees only have access to the specific tools they need for their job, so a database engineer can work on the records without having the keys to the entire network. To keep an eye on it all, CloudWatch monitors the entire system. It tracks server vitals like memory usage, logs errors, and immediately sounds an alarm if any thresholds are crossed. When you stack a VPC, security groups, IAM, and CloudWatch together, you build a comprehensive defense system that protects both the outer perimeter of your app and the internal operations keeping it running. This diagram shows exactly how everything connects. Route 53 and CloudFront guide the user in. The request enters the secure VPC, passes through the load balancer, and hits an EC2 instance managed by autoscaling. That server pulls files from S3 and data from RDS, maybe triggering a Lambda function, while IAM keeps access secure and CloudWatch monitors the entire flow. By snapping these 12 building blocks into place, that fragile local app you started with on your laptop is now a globally accessible, crash-proof system ready for millions of users. Mastering how these pieces talk to each other is what makes a great architect. The individual definitions matter less than the way they all work as one cohesive unit. If this video helped you understand AWS architecture, don't forget to like, share, and subscribe. Follow Avantika Technology for more practical tutorials on cloud engineering and AWS. See you in the next video.